Here we're going to run a little bit of a demonstration of the prevalence count, prevalence proportion, and prevalence odds. This is a little bit of a playground where you can change cohort sizes and how many people in the population have the disease and so on. I'll show you how this works. Okay. Experiment 1. It says set the cohort size to 140. It already is here. You see, this guy here is set at 140. Set the diseased and exposure population to 0. Okay, it's already at 0 here. Increase diseased and exposed in steps and see how prevalence measure changes. So if our cohort size is 140 people and nobody is diseased, then the count is 0. Okay. The prevalence is also 0. Prevalence proportion is also 0. And the odds are 0. So when I said cohort size here, what I meant was that there are 140 people in the population that I'm studying, and I've included all of them in my study. So the entire population is in my cohort. The entire population is in my study. Okay. So what happens if 10 people had the factor? Okay, the red dots now represent the 10 people who actually have the factor that we care about. So the count goes to 10. The proportion goes to 7.1%, and the odds are 0.077. We can increase this to, let's say, 70. Now, the count is 70. The rate is 50%, so half the population have the factor, and the odds are 1. Okay, so you see how the odds are 1 now because they're equal in magnitude, the presence and absence proportions. Okay, and as this increases, let's say 128, the prevalence proportion goes to 91.4%, and the odds start going very high. 10, let's go to 139. The odds are now 139 as well. At 137, the odds are 45. So this is why it's not sort of a great communication tool. At 137, the odds are 45. And then I increase to 138, the odds are now 69. And then I go to 139, the odds are now 139. It's very hard to distinguish between those. So at very high prevalence rates, the odds are not a great communication tool. At lower, they're better, I'd say. Okay, have a play around with that until you get how this works. Okay, experiment 2. Now we're going to set the cohort size to 70. What does this mean? Well, there's still 140 people in my population that I care about, but I've only included 70 in my study. Well, I say only, but actually including half the population in your study is quite unique. So the thicker border circles here represent the people in my cohort. Now, when nobody's diseased, then it looks like this. And as I increase the number that are diseased or exposed, or which have the factor, let's say to 10, we'll see what happens. So the red dots still represent people who have the factor, and the thick bordered ones are the ones that have the factor and are included in our cohort. The prevalence count in my cohort is 4, while the prevalence count in the population is 10. So not a great sort of, and saying that, the prevalence count was 4 doesn't really tell us anything about, well, what would it look like in the population in general. The prevalence proportion in this case was 5.7% in my cohort and 7.1% in the population. The odds are 0.061 versus 0.077. So you can think about this right column here as the truth, if you like. So that's what we're trying to get to. But we can't include everybody in our study, so this is what we get. You can play around with this. Let's increase this to, let's say, 40 cases in the population. So this is for the population, how many cases are in the population. We were able to sample 23. We measured a rate of 32.9%, and the true population rate was 28.6%. The odds were 0.489 versus 0.4. And I should mention that when you change this, the system behind that does this makes a true sample. So it really makes a completely random sample of the population. And you can get unlucky. I don't know if I can get unlucky here. Let's see here. The population, or the amount, the degree to which the factor is present is 101 in the population. The population count, the population prevalence count is 101. In the cohort, we have 56 because we've only sampled half the population. We estimated a prevalence proportion of 80%. The true prevalence proportion was 72.1%. We estimated an odds of 4, while the true was 2.59. Again, I'm talking down the odds. I'm bashing the odds, but again, you see how the you can get, if you're not very careful and understand the odds, you can get fooled by big changes in odds, which actually don't translate to such big changes in the prevalence proportion. And as this grows, well, you can play around and see what happens. Okay, but as I mentioned, rarely do we get half the population in our cohort in our study. So in experiment 3, we set it to 14. Now I've sampled 14 people, 10% out of my population, which is still good. Getting 10% of the population in some studies is impossible. That would be a dream number. So this isn't somehow a nightmare scenario. It's a rather good scenario in some cases. Now you see that the population is quite big and we've only sampled 10%. And as everything is set to 0, and as I increase this, let's say that we have 14 people in the population that actually have the factor. In this case, we captured no one. We were unlucky in the sense in our sampling that we got nobody with a factor. And this is this isn't the system sort of tricking you, it's a true random sample of the population. So we estimated a prevalence proportion of 0%, an odds of 0, while in the population, the true proportion was 10%, and the odds were 0.11. So this should not be unsurprising. This might happen. Obviously, when the population, the count of the factor in the population increases, we're more likely to get somebody in our cohort that has the factor. So if half the population actually have the factor, then in this case, I got 11 in my cohort. I estimated the prevalence proportion to 78.6%, while the true value in the population was half. I estimated the odds to 3.667, while the true odds were 1. Okay? I think it's good to play around with this and understand this, see how these measures change due to randomness, and understand why we sometimes need to think about single studies and single surveys not necessarily representing any kind of truth of the underlying population. And that while this is not a biased study in any sense, I haven't tricked the system, it's a true random sample, a random sample will also be misleading sometimes.